Howdy crew, got a little project to work on. Let's get to it. Howdy crew, I'm William Morris, President and CEO of the Welding Cowboy Corporation, certified licensed welder and owner-operator of a welding rig based out of Los Angeles, California. On here I'll be going over welding knowledge, what it's like to own and operate a welding rig, welding blueprints, welding math, welding equipment, and so much more. Welcome to the channel. I'm William Morris, the Welding Cowboy. So today's project are armrests for a mobility scooter, and the issue the client has is they're a little bit too short. They may be about 4 inches taller, and these are just aluminum square tubing pieces. I was thinking about just splicing it, welding it, and then just putting some extra reinforcements on the side. But what got me thinking about that is I don't know what alloy this is, whether it's even weldable or not. So what I did was I just went ahead and bought some 3/4 by 3/4 tubing, and it's the same size as this. What this is going to have, it's going to go into the mobility scooter itself and just have a little screw that tightens it. Now the issue over here is you need to be mindful that there's a screw here that keeps it level, and what I'm going to do just to negate having to worry about creating another one of these is just have a little piece of tubing come off, maybe 1/2 inch, 3/4 inch, so that way when it folds it will keep this level. The owner of the mobility scooter didn't need any particular angle, so level will be perfectly fine, and that way these can still go up, but then if they need to be folded back to a level position, they will be good. So what I'm going to do is I'm just going to have a 90-degree miter joint, so 45-degree angle, and I'm going to round it off because the owner of the mobility scooter does have grandchildren, and I don't want a perfect little edge there, so I'm going to grind that off with the grinder if it doesn't get taken off a bit by the actual TIG welding itself. So I'm going to see how that goes. If it's a little bit too square, then I'll just grind it off and I'll make a little bit more round, and I'm just going to play that by ear. But I'll have to also drill a hole so that way this fits on here, so I will go ahead and get that done. So yeah, so just some basic aluminum square tubing, 3/4 by 3/4, and just gonna replicate these pretty much just with the 90-degree angle, which will be a 45-degree cut, and I'd just rather do a 45-degree instead of just a butt joint. So I don't want to just butt up against the side. I'd rather have a solid weld all the way around, and then that way it will have more actual weld on there. So if you look at this, there's actually going to be more surface area to weld than if it were just rounded off just like this. And it's kind of hard to explain. I can show it a bit better later, but instead of just having a perfectly straight weld all the way across, it's actually going to be angled, and so that'll give me more area to weld and more strength, and that's what I'm looking for, because you want to be able to get out of a mobility scooter and put all your weight on it and not have to worry about if there's enough weld. So that's what I'm going to be working on. Use a chop saw and then go ahead and TIG weld it on up. So I do have the ends cleaned and beveled. For all the welding students out there, let me know why the bevel is on here. So y'all thought about that for a bevel? The reason I want a bevel on here, even though it's small, it's not the world's thickest material, is to make sure I have as much coverage with the puddle as possible. So that way the weld rod goes all the way in there and I can just get that penetration all the way through, and then I'll have the puddle coming out here, so it's going to be holding on more material. If I just had a simple corner joint to where it wasn't beveled, then I would mostly have just the weld on top, and I wouldn't really be getting it in. If I had it spaced a little bit, if I had it spaced out just like so, I could get a little bit more in there, but I'm not sure how this is going to react. It's not the thinnest I've welded on by any means, but I don't know exactly what series this is, and sometimes they can go a little bit faster melting point wise. So I just want to be mindful of that, because I did make it a little bit narrow on the inside, and so I have it beveled so that way I can get good penetration in there as well as getting good coverage on top, because I don't want part of the bevel showing. And then for this point right here, I also have it flattened to where it's not a perfect corner on the outside, because I want the weld to be covering that. If I had a corner, it would be melting in faster and it would make the weld a little bit more uncontrollable. Also beveled inside here a little bit, as y'all can see, so that way when it's put together, it will have the weld coming out a little bit more, spreading out some instead of just a huge blob going out, if that makes sense. So I did that for both of them. They're all cleaned up, as well as the other edges. I'm going to go ahead and get a little jig going. So I'll have another one of these holding this one, maybe a couple more. Make sure it's a perfect 90 before I start, and then go ahead and weld two sides before I unclamp it. The reason I'm going to do that, for example, if I start on this side and welded it, even though it's clamped down, the way aluminum is, it's going to start coming out once I unclamp it. Same thing as if I did the outside here, it would start to come out more. So what I'm going to do is I'm going to have it out some, so I can at minimum have two sides welded, this side and this side. If I do it upside down, that's fine as well, but main thing is I'd rather just get the three sides done, flip it over instead of doing it upside down, but it can be done. So yeah, I'm going to try and have it out to where I can have three sides. If I can't, at least get two, so that way it's not going to be separating. As long as I have the weld going all the way to this corner and the weld going all the way to this corner, it can't really separate. If it does, it'd be so minuscule it wouldn't be noticeable for the other two welds. So that is my game plan. I'm going to get those two welded up now. Alright, doesn't look like the other footage turned out of the welding, but I did get it done. Wasn't the best, I'm not the happiest with it, but it was windy where I was welding this, so I'm just putting together. I did have to use a flapper disc on the entire project. The reason being, when I got the aluminum and I picked up the aluminum tubing, I don't know what the supplier did to it, but it looked like it had barbs all the way along, just like on a fishing hook, little barbs all the way across, and there's no way I was going to let that slide for this project. So the entire thing got a flapper wheel to it, and the welds all had to be flapper wheeled some because it's going to be fitting in a tight spot. So I did make sure those all fit, and yeah, I had to melt the edges because the inside, they were just really sharp. So I went with the TIG torch and just melted the inside and then flapper disc the outside. It was just the fastest way I could get it done, and to where the client's grandchildren will not get cut or anything like that. Now, just putting it together, again, not the world's greatest weld, but I will take it for this project. So I do have these pieces. These will be painted, but I'm going to go do the fit up right now. And it was just really windy once I started welding. It wasn't windy when I was cutting it, of course not. Murphy's Law. It got very breezy, so that does fit. Move my hood over. There we go. So everything fits there. And so what I did was have this to where it will fit in like so. So this way this piece will stop it. So go ahead and fit it, and it'll be perfect. The other armrest for this mobility scooter had a screw there, so it's adjustable, but this client said just a perfect 90 degree would be fine, so that's why I made it for, was just a 90 degree. I'm just getting this critter. I got the tungsten in there a little bit, so I was not too happy with that. I was just trying to get this critter done before it got even windier. I was using some masking tape, but the breeze was still getting in, unfortunately, on the inside of the tubing. So on the corner joints, I had to be very careful about that. If you don't know what I'm talking about, for TIG welding, you can put masking tape and it helps hold argon in there. And especially if you know the weight of argon, it is heavier than air, so it goes down. So you can use that to your advantage if at all possible. So I was doing that whenever I could, and it really helped. But I don't have a bleed line, or kind of like a purge line. That's what I always refer to. I know there's another name for it, but I always use those two because kind of same difference. And what you can do is you have the extra line filling up the tubing. So you put a line in here, and so that way there's constant argon going in there. I'd figure out if I can do that with the TIG 17 series torch, and if I can do that with the forning machine, because that would really help. So I'm going to go get this put together and get it tightened up. So this way it's nice and tight. Alright, very nice and snug, and it does with a good amount of force, which is what is wanted. I don't want this just to be bumped and flailing all over the place, so I'm very happy with that. Again, not the happiest about the welds, but I got it done. And yeah, I just added extra on there. I went over it again just so that there's extra metal spanning across, and once it got inside, the wind caught me, and that's why it is messy. So I do know that it's not the prettiest weld on earth. I do realize that, but it just so happened to be the day for a good amount of wind here in Los Angeles. And I tried blocking it with the body, but once it caught some of the tubing, and I could have possibly been in a little bit better spot. I'm not too sure. I was at one point doing it with my knee, and let's see how I want this. This one, I'm gonna have it going through this side. All right, I want them to look the same. That's just me. I want it to look as uniform as possible. So I'm gonna have this Chicago screw. If you all don't know what a Chicago screw is, that's it. Basically, it looks like a screw from the outside, but it's got screw threads on the inside. I use a lot of these for my saddles. So if you ever have conchos falling off of like a Western saddle, they use a lot of Chicago screws. The concho will have threaded inside parts, or even if there's a screw on the tree of the saddle going to the leather, it will have a Chicago screw a lot of the time. Just get that lined up. So this piece is fitted. I'm just going to go ahead and get this lock washer ready to go, and then the Allen head screw. Again, I want the screws to be uniform, so if the Chicago screw is going in on the outside of one, I want it going in on the outside of the other, and same vice versa. If it is on the inside of one, I want it going inside the other, because it looks more uniform. To me, it would just look tacky if it didn't have that. And this will all be painted. I think it might even be powder coated. I'm not sure. I'm not the one doing that. That will be in the client's control, in their domain. So get this tubing again, went to downtown LA. It does go down, so I'm happy about that. It works great. No need for an adjustable screw, and it will just rest there. Not too hard to open or close. Same thing with the other one. So very happy about that. Another project in the books, ready for the next one.